So this is our experiment by 3B, levitating balloons. So for our question of investigation and main ideas, we wanted to find the charge of two balloons when statically charged. So there are two types of electric charges, which are positive and negative, and electric charges are neither created nor destroyed. So these two objects that have same charges will exert a force of repulsion, and two objects with different charges will exert a force of attraction on each other. So during this experiment, we use Coulomb's law and force of tension. We set them equal to each other and solve for Q, which is the charge of the balloon. We are assuming that Q1 is equal to Q2, and also we're assuming that they're not attracted to other objects in the room. And we concluded that the two balloons exerted a force of repulsion on each other, which means the two charges were the same.
So for relevant models to the system, we use Coulomb's law, which states that like charges repel and opposite charges attract, with a force that is proportional to the product of the two charges and inversely proportional to the square of the distance between them. We also use net force, and net force is equal to the sum of all forces acting on an object. To find a missing variable of force in a free body diagram, this equation can be used to identify the equation of that force. We also use force of tension. This is the force that is transmitted through a rope or string when pulled tightly by forces acting on either end of the string. Force of tension is necessary to know so it can be applied when finding the Coulomb's pair for the force of electricity. For experimental design, we use two balloons, two 53-centimeter strings, a meter stick, a scale, and a head of hair. Step 1, begin by weighing the balloons on a metric scale. Step 2, tie each balloon to a string of the same length and tape the non-balloon end of the strings to a meter stick. Step 3, rub balloons on hair for an equal amount of time, around 15 to 20 seconds. Step 4, carefully let go of the balloons and observe and measure the distance between them as they repel each other. And be sure to keep the meter stick parallel to the ground. Step 5, record the findings and repeat the trial 2 more times. Step 6, using the data collected, find the charge of the two balloons.
So we collected our data. We found that the length of the string on both ends is 53 centimeters. We weighed the two balloons and found that they were both 2.64 grams. For Kc, we wanted to convert Newton's meters squared over Coulomb squared into grams times centimeters squared over s squared times Coulomb squared. To begin, we found R values, and for each trial they were different. We had an R value of 7, 5, and 6 consecutively. To find the angles, we took R cosine of the length times the R value. To find the force, we took the cosine of the angle and multiplied by the mass times the acceleration of gravity and divided that by sine of the angle. And to find the charge, we took the force, multiplied that by R squared, divided by our Kc value. And we found our charges to be 9.41 coulombs, 3.41 coulombs, and 5.91 coulombs. So our scientific reasoning, Coulomb's law explains that like charges will repel each other just by nature. And when a neutrally charged object interacts with a charged object, the neutrally charged objects, they both have equal amounts of positive and negative charges, and the unlike charges on the neutral object will move towards the charged object, and the neutral object will have whatever is remaining. Our potential errors would be limited precision by the measuring distance between the two balloons, the meter stick not being steadily held, which would possibly give skewed results, and limited precision when creating charge by rubbing the balloons against the hair. Thank you.